officially welcome everybody. I think maybe there are still a few people going to dial in. So the reason why we're here today is to showcase the fantastic project of Allégra in Luxembourg. It is a perfect example of how to work with CREE. The importance of early engagement of the stakeholders, designed with CREE System in mind from the very start, and collaboration with CREE Network. So we're happy that you all join us today. My name is Julia Köhler and I'm Senior Structural Consultant at CREE. For those of you who do not know CREE, I will give a brief introduction of our company and network. CREE is an international construction collective for sustainable building solutions. We are orchestrating in Europe, Asia, and in the United States. With our unique timber hybrid system, we enable our partners to build smart and green. And now coming to today's program. In a moment, my colleague Wojciech is going to take you on a tour through the Allégra building in Luxembourg. Afterwards, we will have a Q&A with Quentin Demain, project manager at CDCL, which you could see for a second. With regards to the tour, originally the tour was planned to be live, but because of COVID and further reasons, we decided to pre-record the tour and show you this very recording today. A huge advantage is that we were able to do the recording earlier in the day, therefore the light was much better than it would be now at 4 o'clock. Okay, maybe I just want to remind you one more time to please switch off your cameras and microphones during the tour, and please keep posting your questions in the chat. We will answer them after the video recording. And now, without any further ado, let's start. Welcome to our virtual CREE building tour of Allégra. And Wojciech, could you please start the video?
Hello and welcome to the building tour Allégra in Luxembourg. My name is Wojciech Niedzwiedz. I'm a senior building services consultant and I will be your tour guide today. We'll be using those HoloLens 2 glasses, so you will be able not only to see the building itself, but also some augmented reality images that we've placed to make it more interesting and interactive. We'll start our tour here in the office of CDCL, who are the general contractors who built that project Allégra. And they're also our licensed partners in Luxembourg. After the brief introduction and explanation about the building, some data and facts, I'll move over across the road to where the new project is being now completed, and then we'll come back to Julia and open the floor to you. Hopefully you will have lots of questions and we'll be able to answer most of them, if not all of them. So without further ado, let me put the HoloLens. We'll switch them on. And I will see you very shortly from the other side. Now you can see what I see through the glasses. You can also see the augmented reality object that we've placed here. Let me put it in context. Here on the left, you can see the existing building in which we are at the moment. Back in 2017, CDCL were considering looking for different ways of construction using prefabricated technology and using renewable resources. And that's how we started our relationship with CDCL. After a number of meetings and conversations and their visit to our office in Austria, they realized that CREE could offer viable technological solution. So we created this 3D model to represent how the existing building would look like if it was built with CREE. And that led to creating a cost estimate, which the bottom line was showing that if the building was built with CREE elements, it would have been about 4% more expensive than the traditional construction. Now, this didn't take into consideration a number of factors. Like, for example, that the building CREE system would have been completed 4 months earlier. So obviously that's a huge benefit to the owner of the building to be able to rent the space 4 months earlier. Also the carbon tax savings because of use of renewable resources. But other factors which are difficult to measure in non-monetary terms, like CO2 savings, the carbon footprint savings, the fact that the elements are prefabricated and therefore the quality and precision is much greater than building on site. And also health and safety aspect, obviously there's less potential for accidents happening on site rather than having them pre-manufactured in the factory. So at that time, CDCL were considering building their new headquarters, and it was an obvious choice that they would go with CREE system and design their new offices with CREE. They've appointed an architect who created that image, how the future offices would look like. And in fact, this building is nearly completed, and CDCL will be moving into it, and they will be occupying the entire ground floor, and the upper floors will be up for rent. Whether the reality meets the architect's expectations, I will let you be the judge of that, because if I move across the room, come closer to the window, here you see the Allégra building in its full glory, with the only difference being a dark sky on the November day. But other than that, I believe the architect will be very pleased with the final outcome. So I'm going to take you over across the road and show you the building inside. But before that, let's have a look at the plans of the building so you have an idea of the size and geometry. So as you see, the building is based on a regular grid, 2.7 by 2.7 meters, which fits perfectly to the CREE slab elements. It consists of two separate almost buildings, the north and the south wing, joined in the middle with a huge open plan lobby with the staircase and elevator shafts. Each half of the building has its own center core with additional staircase, toilets, washrooms, and mechanical service risers. As I said, CDCL will be moving to the ground floor. The remaining floors look almost identical. There's only a slight difference on the ground floor. There's a setback, the first two grid lines creating like a canopy overhang. And on the top floor, there is a cutback as well. And there's a terrace facing the Luxembourg city center. So it's a nice view from the top of the floor over there. The building consists of 4 floors above ground, and there are also 3 stories below ground for the car parks, and there's also a gym or fitness studio and in the basement for the employees. Now, one of the reasons why this project is such a success story is that the CREE design was considered at the early stage. So the building is based on the regular grid. There's a huge amount of repeatability of the same elements. And the fact that the mechanical engineers, architects, and structural engineers were working on this project and were involved from the very early stage of the design. So if you think about this, the 3D model was created not only to provide the coordination between all those trades, but also it's very easy, once the model is created, it's very easy to split those elements. If you think about all those elements have been created using Revit families, which are available on our platform. And it's very easy to create a schedule with quantities and then also calculate the cost of the project. So that's another benefit of this digital twin that gives you the cost certainty. And if I take this image away and show you the typical floor plan split into number of different slab elements. If you disregard some smaller cuts for mechanical services, there were only 4 different types of slabs required for that building. And if you consider this 1,212 slabs altogether and some 250 columns, that's really huge amount of repetitions, and that's what makes the project financially viable. The 3D model was also created to show the phasing and the sequencing of the construction and assembly. So here on this image, you can see that we're using one tower crane and one mobile crane. The tower crane was used to lift all the wall elements and the concrete core, and the mobile crane was used to lift all the slab elements. Typical wall elements is about 3 to 4 tons. The slab elements, 7, the heaviest one, the corner ones with the concrete edge beams, about 8 tons. So that was the first phase when they erected the concrete podium and the concrete core. And in the next phase, the north part of the building was erected. And the interesting story is that it took about 9 weeks to erect that part of the building. And there were many reasons for that. It was longer than expected. The main reason was adverse weather conditions. You may remember in summer, there were terrible floods in northern Germany, and also affected that part of Benelux, and the torrential rains. So the construction site had to be stopped for some time. That we were in the middle of the pandemic as well. And also one of the factors was the delivery that was scheduled to bring the slab elements was 3 trucks per day. Each truck can take 3 elements, so they had 9 elements per day. And as they were progressing with the installation, they realized they can install those 9 slabs within, say, half a day. So the other half a day wasn't that productive. So they had to rethink how to reschedule that in the next phase, and that's exactly what happened. This is the third phase of the project when they erected the south part of the building, and it took them almost half the time they were able to save during the construction. So it's about 4 weeks this part was completed. They were using 2 teams of 4 people plus the crane operator. The first team was responsible for bringing the elements and putting them in position, with the second team to follow, joining those elements and filling the joints with the mortar. All the wall elements came from Trier, which is across the border in Germany, not far from here, whereas the slab elements were shipped from Bremen. That's about 500 kilometers from here. And despite the significant distance, it was still financially viable and commercially viable to ship them from there, rather than find a local manufacturer in the area. So now I think you've got enough sort of background information on the building and the story and our collaboration with CDCL. I think it's the time when we move across the road and I show you the building inside. So again, I just need to put my safety shoes, because it's still construction site, and my high-vis jacket and helmet, and I'll see you on the other side. Now we are inside the Allégra building. We're just walking onto the second floor. You see lots of construction activities are still happening. The fit-out in the south part of the building, we unfortunately can't access there, but we've been given access to the north part of the building. You see the raised floor already installed. There's relatively few activities happening. On the opposite side, the space was already rented out, and that's why they are fitting out the interior partitions, floors, and finishing the MEP services. You see here, MEP services are pretty much completed. One thing missing will be a bulkhead to cover all those services in the middle, but you see all this exposed timber. You see the timber beams and load-bearing columns. One thing that's very difficult to describe is the smell of wood, and despite the fact it's still a building site and a little bit of dust around, you can really smell the wood. I can imagine it would be a very nice atmosphere for people working in here. The building spans about 40 meters across and 16 meters wide, and you can imagine it gives huge flexibility for the interior designer to design the internal layout to suit any particular tenant. From the structural point of view, the building is well balanced. It has a central core that provides the stability in a vertical plane, and because of the wall being separated quite far from the central core, additional stiffening was required. So the architect opted here for this diagonal column, which looks very nice and fits the character of the building. You can see a typical grid that spans from this point here across that point. That's 2.7 meters. You can see the concrete beam at the back, and it goes across 8.1 meters to the middle girder, and it's supported on that middle girder, which unfortunately we can't see it right now because it's already encapsulated with gypsum boards for the fire protection. For those of you who are familiar with CREE System, I don't want to spend too much time describing how it works, but we've prepared this 3D model representing the idea. So you've got load-bearing columns here with the steel pins, and on the other hand, it represents the central concrete core with the L-shaped steel bracket fixed to the wall, which provides the support for the other side of the slab. So the slab has a cutout in the timber beams here, which are resting on that bracket, whereas on this side it's a edge beam with the openings which sit directly on top of the steel pins. I'll try to position as precisely as I can. You see that slab fits directly on top of those pins. Obviously it's not scaled, but you see on the other side it should fit to the top of the bracket. There's another slab we've got here. So again, you see the cutouts in timber beams on the left-hand side, and the ring and the edge beam on the other side. So again, let me try to position it. Once the first slab is installed, the next one is being positioned adjacent. Again, I need to move back in order to be able to grab it and try to position it as closely as I can. I think the crane operator would have done a better job, but I think it gives you an idea how it works. So once the two slabs are positioned next to each other, there is a small gap in between them, and that's where we've got a shear connector, and then the gap is then filled with grout. I think we've got another example of another type of connection. Again, the wall connected to the load-bearing columns, slabs, and the middle girder. So again, it's the same idea. There are openings which are not shown on that particular element. So this portion of the concrete that projects over the timber beams has openings which would fit directly into the pins on top of that middle girder, and that would sit on top. And again, the next slab is positioned adjacent to it, and there you go. So it's as easy as putting virtually Lego blocks together. Typically, it takes about 20 minutes to crane one of those elements and position them on top. And as soon as they are positioned, the second team would come and would fill the gap with the mortar or grout. So that's how the system works. When it comes to the wall elements, all of them were prefabricated in factory conditions. So not only the outside, even including the additional timber buttons, architectural sort of features, but also the inside with the seals, windows, and the gypsum board. That was all prefabricated and delivered in one piece. So another fascinating detail about that project was that for the first time we didn't have to use the external scaffold towers when the elements were put together. There was obviously an issue of protecting them from the weather. As I mentioned, there were terrible weather conditions back in summer, but I'll show you a few other slides to explain how that was taken care of. but the fact is that for the first time we didn't have to use the scaffold tower. That gives us also an idea for the future how quickly the buildings can be erected. We've got a few slides prepared for you to show you the whole sequence, how the wall elements were assembled. So as I mentioned, this one shows the setup in the factory. The elements are built. Here you see that it's only the gypsum board missing, and they will be ready to be shipped to site. If I have a look at this picture, shows concrete core being already completed, and the first elements, wall elements, are being delivered to site and hoisted into position. So the first phase of the project was, as I mentioned earlier, was the northern part of the building, the northern wing, and you can see the first elements being assembled position on the ground floor. You see they're already protected with some plastic sheeting, and you see lots of water on the floor. Obviously, that the weather conditions that day weren't great, but still they were managed to protect the wall elements. Here you see the second floor being built, and for example, the entire corner element is delivered in one piece, just to avoid the joints on the corner, and each single element had carefully planned joints which were behind the columns, so they fitted perfectly next to each other, and as I said, no scaffold was required afterwards. Here you've got an example of how the ceiling slabs were lifted and put in position. So this is what I mentioned before on our 3D model. You've got this concrete portion projecting over with the openings, and they fit directly on top of the steel girder. Here you've got another panel being lifted and positioned, spanning from the wall to the middle girder. And what I mentioned before, once the two panels are put together, there is a gap between, and what we use in this particular project was this shear connector, 10 buckle connector, which just adjusts the position of two slabs, and the gap between the beams is between the slabs is then filled with grout. And that's when the north building was nearly completed. We already started the south part. You will see that that's the only part that wasn't fully prefabricated was the top floor. The reason being is because of this parapet wall overhanging onto the roof. It was over 3 meters high, so we weren't able to manufacture it in one piece because of the delivery constraints. We weren't able to take elements over 3 meters high on the lorry, so that's why this element was split into two sections. So the parapet wall was installed as an additional section, and that's why those timber buttons weren't installed in factory. They were fixed from the cherry picker afterwards. And here you go, nearly completed building, north and the south wing, completed, timber battens already installed. Now all the works were concentrating on the core, fitting the glazing, the curtain wall. Very often in our virtual tours we concentrate on the architectural and structural details of the building. But because of my background being an MEP engineer, I wanted to talk a little bit more about the MEP services, because I find it fascinating and very interesting solution that was adopted in this particular building. Those who are familiar with the virtual tools from IZM and from LCT1 would probably realize that the gap between the timber beams is typically filled with mechanical services, and then it's covered with the radiant panel. So all those services would be hidden from view. Whereas here, you've got exposed concrete and only sprinklers and the smoke heads are visible. So if you're wondering how the heating is provided in that building, it's because we're using thermally activated concrete. So the concrete slab that you can see just directly above, there is a capillary tube, capillary mat installed during the prefabrication process. And when the slabs are being delivered to site, the only thing that you would see is like here, those two white pipes for the flow and for the return of the water. So how the heating works in that building is in summer, when all the thermal energy in the building that comes from the solar radiation, from people inside the building, from light fittings, computers, and any other electric equipment, it's absorbed by the cold surface of the slab, and the water flowing through those capillary tubes dissipates that heat back to the heat pumps in the basement and down to the ground, because there are not 38 boreholes, 90 meters deep each, which then act as the geothermal energy source for the building. And the same in winter, the warm water flows through those capillary tubes, heating the concrete, and concrete being very good thermal energy storage, mass storage material, radiates that heat, warms up the surfaces and the people inside. So this is a very energy efficient solution. Other benefits is obviously the temperature spread across the space is very equal. There is no noise from any mechanical parts moving, and it's very inexpensive for the maintenance purpose. When it comes to ventilation, the air handling unit, which is located on the roof, brings the fresh air, tempered fresh air via the heat exchanger, and that goes in the riser vertically down the full height of the building, and then comes to each floor. And you see here ventilation ducts for the air supply on both sides, and in the middle the return air. So there are outlets from the supply. You can see in the future that it will be covered by the bulkhead, but it will be still almost 2.5 meters headroom below the bulkhead, so the fresh air will be delivered between the beams across the space, and will be returning from underside of that bulkhead and back to the air handling unit. You see on the mains water services for the cooling and heating, ventilation ducts, and the sprinkler pipe. And as I said, this all will be hidden in that bulkhead. Everything else will be nice, clean finish, and only the sprinklers will be between the timber beams. The entire building will be very energy efficient. It will comply with the NZEB standards, which is nearly zero energy building standard. It will have a BREEAM certificate Very Good, and energy performance certificate A, which is the highest in its class. And all this will be controlled by a BMS system, bespoke BMS system. Now, when we talk about the BMS system, there is one thing I wanted to mention. CDCL and CREE are part of the research project called Project Sphere, which is just sponsored or funded by European Union. And the reason for that project is to develop a digital twin and provide some digital tools which could then monitor the energy consumption of the building and analyze it, and hopefully find ways of improving how the building can be run in a more efficient way. And we are participating in that project. What will happen soon, once the building will go into operation in January, we will connect the BMS system to the Spheres platform. We'll be able to transfer all the data from the sensors, and then we'll be able to monitor and test those new tools, and we'll keep you updated on any outcome. So this is really a big thank you both to CDCL for allowing us to taking part and using their building as a test pilot project, and to the Project Sphere participants as well. The way that the building is divided from the BMS point of view, each floor is separated into 4 quarters, so potentially can be sublet to 4 separate tenants, and they've got separate meters which can be then controlled and monitored, and energy can be billed directly to those tenants. There's one thing also to mention, there is an array of solar panels on the roof which are able to generate about 27,000 kilowatt hours of additional electricity, which can supplement the ongoing running costs of the building. And there is also a potential for expanding that PV array on the northern part of the building. But one of the tools from the Project Sphere, for example, will be able to establish that additional energy generated from solar panels, and we'll find out whether it's viable to add additional panels, whether that would bring any additional profits. Before we finish, I just wanted to show you a few examples of how they dealt with the adverse weather conditions they had during the construction. I mentioned a few times about this problem and how they dealt with it. You can see on this image, they placed a plastic sheeting covering completely from top to bottom the entire wall elements, which were prefabricated off-site, obviously, so not only the timber columns, but the gypsum board, the internal layer finish needed to be protected as well. So this plastic sheeting was then tucked on top of the wall and fixed with the edge protection that held it together as well, to make sure that no rain is getting into the middle part of the wall where the insulation is. And then when the slabs were delivered to site, the edge protection was removed bit by bit, and the slabs were able to be positioned between the wall and the middle girder that you see on that picture. Also, once all the slabs were positioned, let me bring this picture a little bit closer. Once the slabs were positioned, you see the grout was filled in, and also the green protection tape was placed on top, just to make sure to let the grout settle before the rain could get in contact with it, to make sure it's protected that way. And also you'll see the protection on the edge. There's this black plastic foil was placed to make sure that the rain doesn't get into the middle of the wall. And before I finish, I'll just look across the street to see the existing offices of CDCL. They will be moving very shortly. They're very eager to move to the new premises. During Christmas time, between the Christmas and New Year, the removal truck is coming to take all the furniture and relocate them to the new premises across the road, and they will all get a very nice Christmas present. When they come back from the holiday, they will be in the new building. Sadly, this is the end of our tour. Just wanted to remind you that there is a chat on the right-hand side of your screens. Please ask any questions that you may have. I appreciate we only covered very briefly lots of subjects regarding this fascinating building, but we hope that Julia and her guests will be able to all the questions that you may have. So I will just have a last final look at the building, and I leave you with a thought. Can you imagine your next project being a CREE project?
So welcome back, everyone, and big compliment to Wojciech for this fantastic tour. Thank you so much. And now I would like to introduce my guest today, Kenta Demain, project manager at CDCL, who is dialing in from Luxembourg. Welcome, Kenta.
Hello, Julia.
So actually, I would like to pass on Wojciech's last question directly to you. Can you imagine your next or CDCL's next project to be a CREE project?
As a matter of fact, yes, because we're already planning a next project with the CREE system.
Could you tell us a bit more about that project, please?
Yes, it will be another project for offices, slightly smaller than Allégra. It will cover around 4,500 square meters. And this project will be for the state of Luxembourg. It will. It's called Incubator Bissen because it will be for small startup companies.
Thank you. I mean, we already heard a little bit about learnings from Wojciech from Allégra project. So, what do you do differently from Allégra project?
As the shape of the building is rather different. It will be like a really long rectangular building, more than 60 meters long and 28 meters wide, with 2 vertical shafts. But we kept with the thermally activated concrete. We continue with this system. So what we saw here in the video will be almost identical to what we will have in Bissen. One major difference is actually there are 2 major differences. One will be that we will not have any sprinkler system. And the second one will be that we will not have the middle girder and columns made out of steel, but out of concrete.
How did you manage to go without sprinkler system for the new project?
We studied that with a fire specialist. And with the ITM here in Luxembourg, which is ITM stands for Inspection du Travail et des Mines. And they are the one responsible for the authorization of this kind of building, that we could do it without a sprinkler system.
Okay, I mean, that's great achievement.
Yes.
I mean, Allégra was the very first CREE project in Luxembourg. What were your expectations when you started working with the building system? And what is your opinion about that now?
As we choose the CREE system for Allégra, we were expecting an easy assembly of the different elements and a fast construction. And I'm pleased to say that we were happy to have our expectation meted with the CREE system. Although, as Wojciech explained, we could have done better as a matter of timing. We didn't plan correctly the first surfaces that we built it. We were too slow. But we now learn from that, and we know that we can do more square meters per day.
Which was perfectly proven from north to south wing, I believe.
Yes.
I also think you originally planned to do a little mock-up to practice the assembly, which wasn't possible due to COVID, if I'm not mistaken.
Yes, that was something that we planned ahead of the construction of Allégra, with an institute here which is dedicated to the training of the workers. We wanted all workers to be trained to raise the CREE elements. So we were in discussion to have a special mock-up dedicated to be built and deconstruct and rebuilt again. But sadly, yeah, because of the COVID, this whole thing went away. But we still managed to build Allégra.
Basically learned on the site.
Almost, yes.
Yeah. Do you see at CDCL, do you see an effect to the market now that there's a physical CREE building in Luxembourg?
Yes, that was rather soon after we started the CREE structure. We started to get a lot of demand from different people here in Luxembourg, architects, engineers, real estate developers, and so on. They were all asking to visit the project, to see the project. And also some CREE partners also were really eager to see the project. The one thing is, as the construction is going so fast, some of the people were a bit disappointed where they came to visit that they couldn't see anything because it was already finished.
Yeah, amongst those, some of our other or further licensed partners. Yeah. Actually, we have a question in the chat. Is there a procedure for deconstruction of the building?
Yes, there is one. There is a CREE procedure to dismantle the CREE elements.
Okay, perfect.
And actually, I can continue a bit on this topic because the next project we have will have a cradle-to-cradle certification. And so this aspect of deconstruction is being taken into consideration when analyzing the whole building.
I mean, Wojciech said during the tour that for Allégra projects, you achieved BREEAM Very Good certification. But coming with that, without even trying or going for BREEAM certification.
Yes, it was not something that we planned initially on the process. The thing is, this kind of certification, rather BREEAM or cradle to cradle or DGNB or whatever, it's mainly the decision from the owner of the building. In our second project, the cradle to cradle was asked by the owner of the building.
We have another question in the chat. You said you worked with fire authorities to avoid using sprinkler systems. What would be the height limit to be able to build without sprinklers? Up from how many stories would you need to install sprinkler system again?
Okay, so here in Luxembourg, we have 3 different types of buildings, small, middle, and high-rise building. So all projects are considered as middle tall buildings, and we could go up to 25 meters high with this classification. The only thing we had to deal with was to reinforce the fire rating of some elements inside of the buildings.
And by reinforce, you mean?
Yes, we had to create compartments. Instead of 800 meters compartment, we had to go for 400 meters compartments into the buildings. And also some doors that didn't add any fire ratings are having 30 minutes fire rating.
So with a couple of compensation measures, you were able to avoid the sprinkler system.
Yes, and also we are applying a fire retardant varnish on the wood beams.
There's another question again with regards to deconstruction. Would you please explain a little more about the disassembly procedure, especially with the grouted parts and connections?
Okay, so the grouted part, they have to be demolished. This is for sure. So we have to use a special saw to go through the joints between the slabs and to destroy the connection between the pins and the slab. But the slab is unarmed, and the columns as well, so they can be reused.
Exactly. Also, with regards to that topic, if the digital twin model contributes to the disassembly procedure.
Not really, because the procedure already exists before we started the twin models.
Okay. How well and to what extent were you able to conduct integral planning for the Allégra project?
We sadly couldn't went to integrate the electrical ducts into the slabs because the planification for the electrical installations were not finished by the time we had to put the slabs into production. So this would have been an improvement if we would have had the electrical planning be finished a bit earlier. We could have avoided to have the electrical duct visible on under the slabs. But we, like Wojciech said, we have the heating pipes integrated into the slabs.
Yeah, exactly. Which just shows early decisions to help. Okay. There are no more questions from the audience right now. So we have 10 more minutes.
I was just, can I just interject? I was very, as Wojciech here, I conducted the recording, and I just picked on one thing when I was looking at your digital model. It was mainly the structural elements that were shown in that digital model. Yes. Are there any plans, maybe on the next project, to have both architectural and MEP services also included in that model? That would have been even probably more fascinating to show.
Yes, actually, on our second project, we will have all the disciplines integrated into the model. It's not our will; it's the will of the client. And also it helps for the cradle-to-cradle certification, because you need to have the weight of all the elements in the buildings, and it's way more easy once you have a complete model of the building to get to collect the weight of all the elements.
Understand.
There were just a few more questions popping up in the chat. Which digital platform you use to collaborate with the BIM models?
We are using BIM 360 from Autodesk.
Did all the planners work on the same model?
No, each planner has his model. So the architect has one, we have the structural one, and the technical engineers have their models. Okay.
There's another question about C2C, talking about cradle to cradle. What is the lifespan that has been considered for the building and the parts, and how many reuse of the elements are possible?
Yeah, that's a tricky question, because reusing the elements is possible. The problem is how can you get any warranty on that, and how will the insurance company behave once they know you are reusing structural elements? It's not in our hands to decide that. we know here that in Luxembourg they're making studies about that because they really want to be ahead in this topic. But it's more a topic of norms and regulations.
Mm-hmm.
We will in the next months also help us some studies from the University of Luxembourg. They will study the behavior of the slabs in the long term.
Mm-hmm.
And then from this study they will make prediction of what will be the lifespan of the slabs, and what could be what kind of warranty could you give after a certain time.
Do they also consider the situation of disassembly and assemble the same elements again if there's any influence with regards to that?
Not yet. As so far, they're just going to start with studying the behavior of the slabs within the long run.
Mm-hmm. Mm-hmm.
Because as you have like in French it's called fluage. I don't know in English the term, but it's the behavior of the concrete and the wood. They both have a certain behavior under load within the long time.
Yeah, exactly. Just both materials have different behavior when it comes to creep and shrinkage, and yeah, which especially shows in long term. We have a few more questions. Did you monitor the project costs or construction costs compared to conventional construction?
Yes, we went. We had this evaluation from the start. Like Wojciech said in the beginning, we first run a comparison of the costs from our existing building to a CREE building. So we already knew where we were heading with the cost of Allégra.
Mm-hmm, mm-hmm. Okay, will your next project also feature a facade finish that is already installed during the prefabrication of the exterior wall elements, so no scaffolding will be necessary?
On our next project, the architect wants to have a facade composed with aluminium panels, and we took the decision not to have this facade built up in the factory, because it's this kind of facade is really fast to install, because it's just a matter of clip-on. It's a clip-on system almost. So we took the decision not to install it, but the interior of the facade will be done in the same way as Allégra. Just the exterior, the finish, the cladding, exterior, the cladding of the exterior will be done on site.
Okay. Could you please explain how will be the lighting system? Will light fixtures be hanging on the slabs? Is it usually decided by the tenants?
Yes, we will have like what you saw here in Allégra. In both buildings, we will have lighting fixture hanging from the slabs. The thing is, on our next projects, we are already partitioning the offices. So it's not something that the tenants will have any decision on that. But yes, here in Allégra, we run a first layout of the lighting fixtures, and we are installing them as it according to this planning. The thing is, if one tenant wants to move some of the lighting, he can still do it. Okay.
Okay. Did you already rent the upper floors of Allégra?
Some floors are already rented, not all of them, but some, yes.
Okay. We are slowly coming to an end of our session. We have 2 minutes left. So I have one last question. Are you looking forward to move into Allégra and
Yes,
work from
definitely.
there? Okay, nice. Yeah, if there are not any further questions from the audience, I'd say thank you for your participation. Thank you, Kenta, so much. Thank you, Wojciech, for the recording and for doing the tour.
Yes.
And yeah.
Thank you, everybody, for the participation.
Thank you.
And yeah, as I said in the very beginning, we will send out the recording to all of you and wish you a nice evening.
Thank you.